topic before last, which is doing some web application development using Java. And I explained the motivation for studying this. First of all, it is still very widely used. Many of the applications that we use, such as Blackboard, Blackboard, is built using Java Enterprise Edition. Something like QNB banking, most of the banking applications are built using this Java platform. And the other motivation is that you already know Java, and it will be good to extend those skills to web development. And you will see the jump to, or the extension is not very heavy. It can be managed in a short time, provided that hopefully you still have your JavaScript, your Java skills did not escape yet. So this session I'll drive it through example and explain the key concepts, because to prepare you for the next lab. And then, inshallah, next session I will explain further the theoretical part. And here I'll focus more on the mechanics, how to do things, and what they mean. You go and apply them and come back and explain deeply what and connect the dots further. Now for the next two labs, whatever you do in your next two labs, you will be working on your last assignment, assignment 4. So in this week's lab, you will focus on what I will discuss today, and then this week, you will focus on what we will cover today, and next week you will focus on extending this to read and write from some database using Java. Okay, so first let me give you a very, very quick introduction, although I will go deeper into it next session. So first of all, here is the big picture. You already know something called Java as a programming language, and you used it to create simple applications. Java that you have used is called Java Standard Edition. Although you might not have noticed this extra qualifier, you just called it Java. But whatever you have used is called Standard Edition. There is something, and this one allows you to build desktop applications typically used by a single user. All right? Now, if you remember from the start of this course, we want to do a multi-user application that is large scale, distributed, and runs on multiple machines. It's remotely accessible and so on. With Java, it's much, much harder to do it, if not impossible. So that's why Java has evolved, and there is another edition called Enterprise Edition. So the JavaEE, known as JavaEE, Enterprise Edition. And this Enterprise Edition, it allows you to have distributed, okay, web-based, plus lots of users. You see the big difference? So every version is for different target application types. This is for more web-based, distributed, multi-user applications. This one is more for desktop, single-user applications. So what is the relationship between the two? They are both Java. Thank you very much. They are both Java, and they build on what skills that you already developed through the last few years. So if we use something of some kind of UML symbol, how we can connect these two boxes? Very good. Inherits, or basically extends. This is extends. So JavaEE extends Java SE with extra libraries and extra capabilities to be able to do this distributed web-based multi-user applications. Now, this JavaEE is just a set of API, programming application interfaces, that are standard API. Standard means that people have agreed upon it. So by the way, in Java community, there is something called Java community. There are a bunch of experts that they meet and they discuss online. What are the features? What extra things we can add to Java? It's not evolving just like this by itself, ad hoc. There is people that kind of steer the evolution of this language. And then they agree on what functionality, extra API to add. They don't go and implement it themselves. They let other companies or other people to do the implementation. But they just, let's say, provide the signatures, the method signatures, what extra interfaces we need. And then the implementation is left to companies to do. So for standard edition, no problem. You just go to Oracle website, you download the runtime, you download the SDK, and if you want an IDE, you might download the NetBeans or Eclipse. But for Java Enterprise Edition, you need an application server. You need to download the server, because this Java that you will write will run inside the server. So there are many, many servers out there. One of them, a famous one and the expensive one, is called IBM WebSphere. This is from IBM. IBM WebSphere. Sorry, IBM. This is only for rich people, Q&B and above, not for us. Okay? For us, we will just use a simple application server called, what's the server we'll be using in this course? Sorry? No, IDE is an integrated development environment. That's just a tool to write the code. The one we will be using here is called Glassfish. I will explain this more because this session is more about the mechanics, but I just want to put you in the big picture. But I will explain this in much more details next time. So this is for the poor people. They don't want to spend money on this. There are so many others. Yeah, but like we don't want to go for approvals, and we just want to go to the internet, download free one, and use it. Khalas. No need for any approvals. All right. So, but yes, you're right. In their Blackboard implementation, I'm sure they're not using Glassfish. They are using something, maybe because they use more Oracle. Maybe they are using Oracle WebLogic. Oracle WebLogic. Sorry? Maybe because QU is more Oracle oriented, so maybe they are using this server called Oracle WebLogic. So the idea, what I want to say, and there, of course, there are so many others. The idea is when you want to develop a Java enterprise application, you need to decide one of these servers, depending on how much money you have, what qualities you need. And all of them are exactly the same. Functionally, from functionality point of view, they are exactly the same. They diverge on what? The difference is? No, not complexity. Performance in quality attributes. It's exactly this. All cars are exactly the same. All cars. They all take you from A to B. Okay? But why do we have like Fiat, and we have Renault, and we have Toyota, and Rolls-Royce, and Mercedes? Yes, it's all about qualities. The luxury, or you want them to fancy or just functional. But yeah, but all of them, they all take you from home to QU and back, whichever you take. So exactly the same here. All of these are exactly the same. Why they are exactly the same? Because all of them follow standard API. They all have exposed the same interfaces. Okay? And I will explain this further, but for now this is enough to understand that JavaEE extend SE with extra libraries to be able to build distributed web-based multi-user applications. In reality, this JavaEE is a set of standard APIs that gets implemented by multiple servers. You choose the one you wish based on your budget, based on your quality requirements. But the good news is you can start here And when you get rich, you move your application here with no change, because they are equivalent. Okay, when you get richer, go for Mercedes, but you will still only get from A to B. There's no change in terms of functionality. You'll still be stuck in the traffic and all, and your car will also get dusty and all. Same, but you have some other quality attributes that you get, extra quality attributes. Is the idea clear? Now, let me explain one more concept, and then we go into the mechanics of how things work. So first of all, like let's say if I have a Java program. So usually it has an extension .java, and then you go and compile it. It produces something with extension .class. And then for you to run it, what do you need to run a Java program? You need a runtime, okay? You need a runtime. It's called, what do we call the Java runtime? What is it known as? JVM. JVM, Java Virtual Machine. So your program runs inside the virtual machine. And when your program runs, the Java Virtual Machine translates the instructions into the hardware level instructions. So the reason why we have this virtual machine is that it provides services to your classes, okay, to your code. What type of services? Can somebody give me an example of a service that this virtual machine or runtime provides to your application? An example of service. One is what called the just-in-time compiling. Like, because just when you run the function, it gets translated into the machine code. That's a service. Yes, very good. The other one is called the garbage collection. Yes, when you are using Java, you don't need to clear memory and manage memory yourself. Just release objects as you don't need them, and there is something called garbage collector that wakes up every few, let's say, minutes, or depending on the need, and it goes and collects the unwanted objects. That's an example service. It can also verify your code is not trying to do something harmful. That's a security service. So you can see here, the Java Virtual Machine provides services to your application. So similar to some people live in a normal apartments, and some people live in a serviced apartment. You understand this concept? So what is the difference?
Maintenance, for example.
Yeah, so the service apartment provides what? Services. Example services?
Maintenance when something's broken.
Yes, maintenance, security, like, yeah, gardening, for example. Depend, like some of them, they can even take your grocery from your car to your home. Lots of services. But if you don't have a service apartment, what will happen? You do everything yourself. Protect yourself. If there's gardening, you do it yourself. Everything you do yourself. So the reason why this architecture is nice, because the runtime provides services to your application. Now JavaEE, these servers, the reason we have them is to provide services to our application. Beyond this, so Java Virtual Machine provides services, and these guys provide even more. Can somebody give me an example of service that these application servers provide? Thank you very much. Scalability. With no extra coding from your part, your application becomes multi-user and handle more requests. If you are ready to, this one maybe, let's say, 1,000 concurrent requests. This one, maybe 1 million concurrent requests. Because this one, the free one. If you want more, you have to pay. Okay? So you see here, another one is maybe security. You say only managers are supposed to, let's say, run the payroll or change the salary. You can put some rules, and the server will enforce those rules. If a normal worker goes to change their salary or something, they will not be allowed. Okay? And another example is make your objects remotely accessible without any coding. So you have an object running on the server. You can access it remotely through the web using these application servers. So the idea is, the whole philosophy of having these application servers is to make our life as developer much, much easier. And the low-level details are handled by these application servers. And these are very mature technologies, more than 15 years of development. You can't beat them. Even if you say, oh, I will do everything myself, I want to rely on myself, that's not a good idea. Okay, because these has been tested and matured, and some of them version 10, version 11, 12, many, many years of development. So, and used worldwide and tested, and so very reliable. So that is the idea. Is the kind of the big vision clear? It will become clearer as we go into the mechanics of how to make use of this to build a web-based distributed application using Java. Is so far clear? Okay, now to illustrate this concept, I will start with a very simple application, which is a contacts application. Just I want to be able to add contacts, delete contacts, get contacts. So for me to build such application, the first thing I do, I create what is known as entity classes, okay, or let's say schemas if you wish. So what are entity classes?
You can create objects from.
Yeah, any class you can create objects from. Sorry? Okay, very good. What are entities?
They will
Actors, yes.
or take output from the service.
No, not really. Basically, entities are just information holders or data holders. The role of entities is just to maintain the data. So entities are the major concepts in your application. Let's say a student, a contact, a grade, a course. Those are entities. The objects that make up your application. So the structure of such objects, what do we call them? Entity class. Yeah, all of them are classes. But these are called entity classes. And entity classes, the only thing you find in them, you find some properties, some getters and setters, and maybe a constructor. That's it. They don't have any logic. What is their role in the whole application? Just to store information, that's all, to store data. They don't have any logic in them. Okay? And by the way, I'm sure you know this. So in here I have a contact. Don't worry about this guy. This is annoying. Just a normal class. Okay? But I'll put it back just in case I need it. All right. Here are the attributes. So using a nice encapsulation principle, you make the attributes private, and you provide get to read them or set to write to them. You already know this. We're not going to go through it again. So, and you just define your properties. These are, we back to static language and strongly typed. Everything is typed. There's no let. Finish the idea of let. Everything has to be well defined a priori. You have to define your entities. That's the first step you do. And then, luckily, these things you don't need to write from scratch. You can just generate. You know all of this. Yeah. So you can here insert, and you can insert constructor or getters and setters and so on. So you just define your properties and generate these constructors and the getters and setters. And here is the address. The address is made up of three attributes: street, city, and country. Okay? So for entities, zero change. Exactly the same the way you have seen them before. Any question on this? Okay. So usually, like when you are designing or building an application, you might want to start with the entities.
You define them.
Yeah, what are the main objects in your application and how they are related with each other. You define their structure, you capture this in a class diagram, and then you write them in this case in Java. Either way, like either you have a class diagram and you generate from it the code, or vice versa. You start from the code and you can reverse engineer it to a diagram. Okay, Now, the next step, now you have these entities. And typically, you want to read them or write them to some data source. So that logic to read and write, where do we put it?
Database or files.
No, that is the data source. A repository, thank you. So we have another, no, service is something else. So you see here, every class has a very clear role to play. What is the role of entities, entity classes? Just to hold the data, nothing else. Now, if I want to read or write such data to some data source, either a file or a database or in-memory lists, whatever it might be, I put that logic of reading and writing, where do I put it? In a separate class. I call that class a repository. What is the role of the repository? Read and write from a data source. Is clear? Now, here is the repository I have. What do you think this repository will have? What kind of method do you expect to see? Thank you. That's it. The normal create, update, and get. Let's say add contact, update contact, delete, get all, get by ID, and so on. Okay, that's what you expect to see in a repository. So, if you wish, you can start with an interface, although this is optional. Sorry, here it is. You remember the concept of an interface? It's just a class without implementation. This is not too scary if you want to describe to somebody what are the capabilities, what the repository can do for you. You can read them here without scaring anybody. Just say, this is the repository is able to add contacts. You give it a contact, it gives you back the contact again. It gives it back to you because typically it gives you back the ID of that contact. Because usually the requester does not know the ID. After add, we communicate the ID. That's why we just say, okay, here it is, we return you the whole object. If you wish, you can return just the ID and return int, it's up to you. In here, this is delete. You just ask me, here, this contact 123, no longer good friend. I want to delete it. All right, khalas, delete. Here, this is a little bit unrelated. I want to get the cities of particular country. Okay, you give me the country code, like Qatar or Egypt or Tunisia, whatever, and I give you back a list of strings that will have the cities. Here, if you know the contact ID, give it to me, I can give you back the contact. If you want them all, just call the get and I give you a list of them. And here, if you just want to know how many you have, just call this one. Get contact count, you get a number. Here, if you want to test some data, insert some test data just to get started. And here, if you want to update. All right, so you get the idea of the interface. These are basically the methods that the repository will have. Nothing to do with Java Enterprise Edition, is the normal stuff. Okay? Very good. Normal stuff. We will implement it in another class.
But for some of them, for one of them, we put this add.
Yeah.
To make it like accessible from.
No, we will come to that. Don't worry about that little things. Those little things. I will explain them. Okay, here is the implementation. Because up to now, I don't know how to deal with databases. So I will just keep a list of contacts in the class itself. Here is the list of contacts. Can you see it? It's a private attribute. When you say to me, add a contact, I will just add it to that list. If you say to me, get contacts, I will return you that list. So this will work perfectly, but with no database. Of course, once you switch off the server, everything is gone. That's fine. We will learn how to do a database, and then we will solve this problem. So in the lab, you will do your assignments 4. You just create your classes. You create your repositories. And your repositories, what they will have? In-memory lists. There is no database. But they will work perfectly. Later on, when you know how to do database, you will go and change the repository. Only the code of this one. Okay? Is clear? All right. So far, what I'm showing you has nothing to do with JavaEE. This is all Java Standard Edition. And you should be familiar how to do this. So, Here, when I start, the last contact ID will be 0, just for me to track the last contact ID, because I always add 1 when you ask me to add a new contact. Here is the start. If somebody asks me, please give me all the contacts, I will check. If it's already initialized, I just return them. Otherwise, I insert some test ones. In real life, we don't do this, but for testing, I'm just inserting some test data, and then I return you the contacts. So if you ask me to add, here is the add. If it's null, I initialize it within the list, and then add to it. Add the contact to the list, set the ID to the last ID plus 1, and then return the contact. Are you following? This has nothing to do so far with this box. This is all here. Okay? So that's why I'm going to speed it up. So this is the update. I search for it. Once I find it, I replace it with the contact you gave me, and then finish. I don't return anything because I didn't promise you anything. Void. Here is the delete. This is Java 8. Java 8 is trying to borrow some of the ideas from functional language and the lambda and what they call it, arrow expressions or arrow functions. So in here it says, you can of course do a loop and do the traditional way, but this is more functional way. It says, this is from 8 and above. So it says, go ahead, remove the contact if the ID is equal to the ID I gave you. Is clear? This is a functional expression coming into Java. All right. Now,
And we are not returning ID removed here.
I'm not returning. If you want to design it some other way, it is fine.
Because I remember like we used to get the ID of return, like
In
a deleted one, so you know which one is deleted.
No, not really, because you gave me the ID. You gave me the ID. The way it works, this is the best practice, by the way. If something happens, you get an exception. So no need to return anything. Just do the happy day scenario, and the exception will be raised to the caller if there is a problem. Okay? So this is a perfect solution. Yani. All right, now this is the get. In the get, if this is not initialized, I initialize it. Otherwise, I look for, you see that filter, similar to Java script. So you can do, instead of doing a loop and that stuff, you do filter. But this is the syntax. It's a little bit different, but the same idea. If you are not comfortable with this or you don't like it, I don't think you don't like it. But yeah. So in here, the only difference is that in JavaScript, they hide all the details from you and give you very silky, very sharp, and very concise API. In Java, they still hang on into showing you some of their details. So in here, they tell you, okay, I need to stream it. Kind of, I'm pushing one by one and applying some filter. If you pass the filter, you go to the results. Otherwise, you get dropped. So they say, okay, you stream it, and then you filter it, and this is the filter condition. If it's pass, because in here I'm expecting just one. I do find one, and then I do get. See, it's a bit verbose, more steps needed than JavaScript, but the same idea. Okay, if you want to use a filter, you have to stream first. Stream, this is a list. Yeah, this is the way they have implemented it. It's just, if it was me, I won't even expose that. I will just do array list dot filter. But that's the way they have implemented it in Java 8. In Java 8, you can stream and apply a filter. For you to filter, you have to stream. Okay? And this is the filter condition using an arrow expression. And then, because this is a key, I'm expecting only one. So I do here, find first, and then get that first one. Even if I was me, I would just stop here, find first, and return it. But they are there. That's the API. Here we have nothing to do with this. This is how they have designed it. We learn through the documentation and apply what they told us. All right. So because you might be wondering why is that? Why is stream? Why is .get? So this is the way they have designed it. The API developers. the developers of these features. All right, so let's move on. Here is the contact. So if it's null, I give you 0, otherwise I show you this, I return you the size. Here is the insert. Insert is also quite interesting. So what I'm doing, I'm reading these contacts from this file, which is on the web. So if I go there, maybe it's already open.
It's JSON?
Yeah, it is JSON. Very good. Here's the file. Although the extension is .js, it doesn't matter the extension. By mistake, I called it .js. It should be .json. So what this is doing, it's using this library that comes from Google. It's called JSON, which allows me to serialize from an object to JSON and vice versa. So I create an instance of it. Then I go ahead and read from the URL, I read the whole contents of the file in one string. And I'll put it in this contact string. And then I call this from JSON. So I'll say, JSON, please read this string and convert it for me to a list of contacts. That's how you deserialize in Java. So very easy as well, few lines, you can deserialize from JSON string to a list of objects or an array of objects. Yes? No, you have to download it. It's already included here. Although the JavaEE has JSON serializing and deserializing, but unfortunately, it's very verbose. Lots of coding to do simple things. It is there, but in here I'm just trying to make it as streamlined and as easy as possible. So I decided to use this external library instead, just to make it easier. Okay? Because this one in one line, I can, if I have an object, I can do to JSON. If I read from string to objects, I do from JSON. Very simple. Okay? And then I am converting this array to a list. This is how I convert an array to a list. And that's it. I return. I set this one, the last contact ID, to the size. And that's it. This is how I initialize. Here I am initializing the list from a JSON file. Is clear? Yes, this is all this stuff has nothing to do so far with EE. Is clear? Okay. So I think the last method I have here is cities. This is hard coding. So if you give me Qatar, I return you these cities. If you give me Algeria, I return you these, and so on. Okay, this is hard coded, nothing here. All right. Now, this is my repository. Now, the idea is, imagine I have a web application. I have a web application. By default, we know web applications can attract many users at the same time. And I want them all to use one instance of this class. Are you following? Yes. Because this is shared. It's like a database. It is shared. If somebody wants to get a contact, we will get them from this same list. If I have 100 users, they will all read from the same list. If one of them add a contact, it will go to the same list. Okay, what do we call this pattern of having one instance? Singleton. Okay, what is singleton pattern? What does it say? One object in the whole system. It makes sense here. Why does it make sense here? All sharing it. Very good. Thank you. I don't want every client to have their own instance of this. I want this to be a shared resource. Are you following? So now here is the JavaEE comes into play. I want this guy to do it for me, not me having the headache, bringing my book, how do I implement singleton. I just want the application server where this class will be running inside it. I want it to make sure there is only one and only one instance in the whole application. How do I do this? You just, like in your service apartment. I'm not sure if you've been in a service apartment, something similar to a hotel. So you might have some kind of digital panel with buttons. 1 for security, 2 for room service, 3 for restaurant service. You know what I mean? So you have some kind of dial-up. You just click the button to get the service. Are you following? Now, same thing here. These guys are providing services. You as developer, you just ask for the service and it will be given to you. So what service I need for this class? Singleton. What does it mean? What instruction? Yes. I am telling, let's say we are dealing with this cheaper one, Glassfish, a free one. So I want to tell Glassfish, please, when I start this app, I want you to create one instance of this class and make sure there is only one instance shared across the whole application. So to do that, all I need to do is add this line on top of my class. And this one is called annotation. You see this annotation, it starts with @singleton. What that annotation says, what does it mean and what does it say? So that is an order, isn't it? An order to whom? Thank you. To this application server. Because remember, JavaEE application cannot run the normal way. You have to install a server, take your application, and copy it to that server. So your application can benefit from the services the application provides. And the whole idea is to make your life as developer easier. You focus on the logic and you let the details, the technical details, the communication details, you outsource them or you give them to the application server to worry about. And how do you link? How do you link between, or in another way, how do you request services in your classes? How do you request services? Through this is called annotation. So it's exactly the same analogy. You have this service department with some kind of buttons to request services. You just need to know which button is for which service. Then maybe it's written there already, or maybe they put a card. Even for the traditional ones, they put like a phone, and beside it there is a card, 3 for this, 4 for that, 5 for that, and so on. Exactly the same. So in here, the server is capable of doing this for you. You just need to ask. How do you ask? Through annotation. Is clear? So in our scenario, the repository is exactly the same as a normal Java Standard Edition repository, with one exception. I want to make it a singleton, so I'll add this annotation that is provided by JavaEE, and that's it. Is clear? Okay. Now, later on, when this repository goes to read and write from a database, I will use more annotation to get some more help from the application server. So whenever I do something, I say, oh, can the application server help me do this? If yes, I'll go and learn those annotations and add them to my class to make use of the services.
Normally we just need to do the logic.
Yes, that is the idea. The idea is, that's why I said, if you know Java, you can switch or kind of extend your skills to distributed web-based using your skills that you already know, with some very little effort and little extra knowledge and skills that you need to develop. Now, so far we have the entities, and we have the repository, and we have a single instance of this repository, and it is shared across the whole application. What is the next step for me to make this accessible through the web? Services. So what is a service?
Functionality that the server should serve.
Okay.
Client side.
Yes. So sorry? Provide the connection, very good. Between what and what? Connect the server and the client. A little bit more accurate and more precise what the services are really doing. Yes. No, this guy will do all of that for you. When you start the server, it will be listening, and when there is a request coming to your application, it will give it to you. That we will not do any programming, by the way. That's the power of using an application server. It handles that low-level communication on your behalf. Now, a service, to be more precise, a service is a mapping between a web HTTP request and a method call. This is what a service is. Remember, if the user comes using a GET to a certain URL, I want to run method ABC. If the user comes using POST to URL XYZ, I want to run method XYZ. So what is a service?
A mapping from the request and the client side to a function.
No, more precise, a request between a web HTTP request to a method call. Basically, a service is the bridge between the world of web, the web world, and the object-oriented programming world. Are you following? So I have this object here, but I cannot access it through the web. This one I have to create an instance and then call the method. That's all I can do. But what is my goal? I want to make this functionality accessible through the web. So to make this functionality of the repository accessible through the web, what should I do? Create a service. And what is the role of the service? Mapping. Very good. That's it. You see now every class has very precise role. We have entities. What is the role of entities? Hold the data that the application needs. What is, we have repositories. What is the role of repository? Read and write from some data source. And now the services. What is the role of the service? That's it. Thank you very much. What about the user interface? The user interface is exactly the same that you already know. We will not study it anymore. You know the HTTP, you know the HTML, the CSS, the JavaScript, and you know how to read data from the server using fetch. That will not change. So if you want to move your application from Node.js to JavaEE, what do you need to do? Yes. First, do the entities. Do the repositories, create your services, and that's it. The user interface should work as it was.
We used to use jQuery in the client side, so you will use...
Of course, jQuery on the client side. Yes, yes. Client side, zero change. Because the client side is running, will be running on the client, on the browser, and that still works, no problem. And the client side, in fact, does not care whether you have Node.js, or Java, or C# or PHP, or somebody is just sitting there. When the request comes, they type the results. It does not really care. Okay?
The HTML files, we import them in the Java NetBeans?
Yes. Yes. And you will place them in certain location. Now, Java is very standard way. You have to do it the way they ask you to do it. The reason why, because you have multiple servers. If you do it in a different way, they will not understand what you're talking about. So that's why, have a look at this. The web pages are under a folder called web. I will show you later on. But you just copy them and paste them there. That's it. But we will see that. That's not a problem. Now, let me now switch very, very super quickly to the services. Here are the services. So the services definitely will make use of. Here I cannot hide the JavaEE. Here is the main idea of what JavaEE will provide you. It will make it for you super easy to make your objects web accessible and to make them multi-user with no effort from your side. All through annotations. So you just need to learn the annotations and apply them appropriately. And then the rest, the server will take care of it. Okay, have a look at this. So in here, it says at path, which means if somebody comes to this URL /contacts, they will land in this object. Okay? Now there is another annotation. Don't worry too much about it, but just add it for now. Stateless means, by the way, I will go through this all through slides and so on, but here I'm just showing you the mechanics because you need to go to the lab and apply it. So stateless means this class does not remember anything. It doesn't have any memory. You call it, it does the work, khalas. It doesn't remember anything. So I'm just saying to JavaEE, and I will explain later why this is important. Yes, not create sessions, and this object can be used by anybody. because it does not have any private information from private conversations. So that's why I add this stateless. Then have a look at this. If you want, let's say in a hotel, like there is something is broken, or there's somebody spilled something on the floor, you just call for cleaner. Just press the button and call for the cleaner. So in here, this class, to do its work, it needs a repository. So in here, there is another annotation called the inject. This is a request to the application server to provide an instance of the repository. Remember that we said the repository, there is a single instance. So I don't want to create my own instance. So I'm asking for a reference to the existing instance. Sorry? Sort of. Now, even a require, you create an instance yourself. In here is different. In the JavaEE, it has much more capabilities than Node.js. Yes, Node.js is easier to develop with, but JavaEE has been much longer than Node.js, and it has much more capabilities. In here, I will explain this, but for now, just keep it like mechanical. This is what you want to do, this is how you do it. But the kind of the theoretical background of it, I will explain it next session. So what this line is doing, it's asking for an instance of the repository. That's how you do it. And the server will give you that instance. You don't need to worry. You don't need to do here equal create new repository. You don't do that. Just ask for it, and it will become. It will be given to you. You don't need to call like in the hotel. You don't need to call the cleaner. Please come to this room. You just press the button, and that's it. They will bring it. Everything will be done for you. Just don't worry about it. For all. Very good question. For all. And I will explain what the server really does. Now, here is the start. Well, if you understand this, you will understand the rest. Here, remember, I'm doing the mapping between the web and my objects. So in here I'm saying if somebody comes to my application using a get verb, remember get and post, and they come to this path, which will be relative to the above. So it will be /contacts, /cities, / a parameter called country. So you see parameter is between curly braces. And this method will produce JSON, which means the caller will get at their hand a JSON message. Okay? Now here is the method. It will return a response. And the method is called getCities. And this getCities receives a parameter called country code. And here I am linking this parameter in the URL with the parameter of the method. You can see here clearly I am linking the two worlds, the web world and the object-oriented world, through annotations. So if somebody comes using get to this path, they will tell them the good news that they will get JSON. And by the way, this is a parameter. It will be passed to this method parameter. Here, don't worry about this. Here I was just trying to simulate something that run for a long time. We don't need it. This one is just my own thing to make it longer running, to simulate some other stuff. So all I'm doing here is my object-oriented. Here, nothing to do with JavaEE. I'm just calling getCities, sending the country code. I get the list of cities. Then I'm just displaying them just for debugging. Then I'm using my JSON object and serializing this list to a string, taking that string and sending it back as a response. So I'm sending a response with 200 OK. Remember the 200 OK? And this is the body of the response. And I say build, which means take all of this, build a JSON message, and return it back to whoever called this URL. So through these simple things, I am making this web accessible. Can be accessed throughout the whole web. Annotation? Oh, okay. No, you don't need to even worry about that. Because your server, when you install your server, you decide which port the server will listen into.
Okay, when we decide this?
You don't, at the time of installation. When, okay, like when you rent, let's say, a service apartment, you don't need to worry about the details. You just need to know about the services, press them when you need them. So the port and this stuff, you decide them when you install the application server. Yes. So a server can host many applications, and all of them listen on same port. Yes. Yes. Same port, different URLs. You might have /contacts, you might have /jobs, /courses, so different URLs, same ports. So the server listens on the same port. When it says, oh, /contacts, it will give it to this class. /jobs, it will give it to the jobs class. /courses, it will give it to the courses, and so on.
Under that,
Yeah.
you used to put the full URL.
No, you don't need, here you don't need. Yeah. Just a relative.
You started with contacts, but each time you will start with this first and then build on it.
Yes, yes. If you don't want, you can comment this and put @path in each of them.
Okay.
Yep. Yes.
If you have different, like what you say, bigger subparts.
Bigger.
يعني the first one is /contacts.
Okay.
Inner, صح? Something inside it.
Yes.
If you have another big one that has
You have another class. Let's say jobs, job service, courses service.
different services.
Yeah, different services. Each service a different class. Because of cohesion, you need to keep things that are related together. You don't put here get weather, get jokes.
To do the app on JavaScript كان عادي يعني you start with different.
Even that one, like as we move forward, we have different controllers. Each controller has related methods together under one roof. So for cohesion and better understanding, we keep things organized by keeping related things together. Yeah.
For the local host, is it necessary in their ports? Well, I need to specify that.
No, localhost is the name of the machine. Yeah.
I need to specify that API will know automatically يعملها.
Sorry, can you? Oh yeah, yes, I see what you mean. So remember, first I get this, I download the server and install it. Okay. Then I develop my class. Then I compile it and copy it to the server. Okay. So my service will be the name and the port of the server / the name of the application / the name of the service. Yes, on the local host. Sorry? You can change it too, sorry? Other machines? Yeah, of course. You can run it on any machine. Like basically, your local host, I'm putting here local host because this I'm using it locally. But remotely, I will put the name of the machine, like my PC or some other. So no, we will see this in more details, and in the lab also. Sorry, just a second. I will just stop this one.